discussing a seminar I just attended at the Human-Centered AI Institute at Stanford. Mark Haber is his name, the presenter. Here's the gist of the talk. The talk is about intrinsic motivation, curiosity, and agents that exhibit those things, and then also about how to develop large language models and deal with large language models and intrinsic motivation and curiosity. Now, the reason this is an important topic, and I want to talk about this in the podcast, is because this comes along as the exploration versus exploitation problem in reinforcement learning. It also opens up the question of how do you actually want to train, let's say, large language models, because large language models have two training segments, if you will. One is the pre-trained transformer, and then there is the fine-tuned object modeling, or in other words, once the transformer is trained, human reinforcement learning and on all of that stuff plays a role in actually making the model do what you want it to do, or be good at particular things that you want it to do. So this goes back to, again, motivation and curiosity. So I want to focus on those two aspects of the talk and discuss in particular the concept of motivation, because there is a good question, which is, well, any agent has motivation. Otherwise, what is the agent? An agent with no motivation, by definition, is not an agent. So that would be number one. Then curiosity, the exploration problem. I think it's a big problem because this is not just in programming. This is in life, right? How far should you go in exploring something? And we at Orange Capital Partners have thought a lot about the long tail curiosity problem, which is how far can we go with very little payoffs, but then expect a long tail payoff. This is also, if you want to use a technical term on Wall Street, this would be long volatility. This would be long dispersion, long unexpected events. So that's a big question. I asked Mark about these things. He didn't really have good answers. I would say he's one of those people with very interesting thoughts and interesting comments, but very little substance, actually. But that's okay. I don't want to criticize him. I was still thankful for the talk. And just for new listeners, the reason we do these conversations about books, about seminars, and any kind of interview or whatever we do here at Orange Capital Partners, it's because the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund, and it's incredibly important for us to come across as that a lot of our work is actually understanding new things. I mean, this is exploration, actually. Okay, we're going to a seminar, we're thinking about motivation, curiosity, exploration, stuff like that, and we don't know what's going to come out of it, but it's definitely going to shape our thinking. It's going to shape our understanding of the world, and this is the business we're in. We're in the knowledge business, and going to these types of events is exploration. It is creating new ideas. It is creating, if you will, we are curious. I mean, we are by definition curious, and we're going to these events, and they might be a long tail. Actually, going to a Stanford lecture is not a long tail event, because no matter what, you meet interesting people and you'll have some interesting ideas. This is a Not Even Wrong podcast. It's October 11, 2023. This is Krim Telko. We are flat for the day. For the year, we are up 127.5%. The market is up 13.2. We're outperforming by 114.3%. The market's still open. These numbers are subject to change. So the talk was about intrinsic motivation of agents, about curiosity, and about how to apply this to code assistance in large language models. So those were the main topics of the talk. I'll put the talk in the show notes for if people are interested. This is the Human-Centered AI Institute at Stanford, doing these seminars once a week. Very interesting. definitely worth going. So let's start with intrinsic motivation. So intrinsic motivation, as far as Mark is concerned, is just something that you do anyway, right? That's something you don't need to be, um, paid to do, uh, but like if I use the David Deutsch line, if I know how to program it, then I understand it. If I use this line, then how would I program intrinsic motivation? And my answer to that is there's no such a thing as an agent without intrinsic motivation. Every agent has intrinsic motivation because minimizing a cost function, that is intrinsic motivation. So this is the way I see it, and I think that's maybe a little bit lost in semantics here, but I would say that every agent has intrinsic motivation. Otherwise, they're not an agent. So if somebody is randomly doing things with perceptibly no motivation whatsoever, then they're not an agent, because then they don't have agency. We don't know what they're going to do. In other words, in order to predict what somebody's going to do, I think we need to have intrinsic motivation. So I asked Mark, let's say AlphaGo Zero, right? AlphaGo Zero was programmed in a way that it had no prior knowledge of anything, and then it was trained to win the game of Go, and it did that. And it did that in very interesting, creative ways. So it had intrinsic motivation to win the game, but it had no intrinsic motivation to do any kind of step A, step B, and those sort of things. Let's talk about the second thing, curiosity, which I think is really interesting. That is, in sort of layman's terms, curiosity is just simply, okay, how far do I go with unknown things? How far do I deal with uncertainty, or how big of a variance do I tolerate in my outcomes when I do, let's say, the next step? And that is, of course, defined also by payoffs, because I'm not going to be curious if there's no payoff in being curious. So I think I asked Mark this question too, and his answer wasn't very good. I don't think he has thought about it too much. So how would you program curiosity? And this is actually something that in reinforcement learning is very common. It's the exploration versus exploitation problem. So if you're in a local optimum, how far away from that local optimum do you go? How far do you explore, right? Exploration. And I think that in itself is programmable, but it all depends on the payoffs, right? I use the example of, if you walk around in New York City, then curiosity is cheap, because no matter where you turn, left or right, you're going to have an interesting experience. So it's cheap to be curious. If you're curious in, let's say, in science, around the 1910s, 1920s, when quantum mechanics was discovered and developed, it was very cheap to be curious back then, because no matter what you came across, the chances were you're going to win a Nobel Prize. The Pauli exclusion principle, the Heisenberg uncertainty, they were coming up with stuff every day. It's much harder in a field that is more developed, because then you're going to start focusing on more established things, incremental things, and so this is a long lasting question: incrementalism versus disruption. This is about, should I go the unbeaten path, or should I stay on the path? What's my risk? What's my career risk? All those kinds of questions, they all are summarized in here. So I think it's an interesting subject. It's something to be thought about, and quite frankly, it hasn't been solved very well. We at Orange Capital Partners think a lot about this. It's our job, actually, to try to be curious and also try to do long tail payoffs, right? That's the big problem here. Can we do payoffs that have long tail? Venture capital does it. They do it through diversification. So one of the solutions of curiosity, let's say in venture capital, is just to have many curious paths, and then, whenever something pays off, you get paid for all the other failures. Last thing, he spoke about code assistance, so GitHub Copilot, and I forgot what the Amazon name is for that. The idea of helping people write code. Now there, I would say the problem is, okay, if you write code line by line, then mistakes happen. Or bugs, or it's just going to be incredibly expensive to write code line by line. It's much better if you write code in a predict the next word type of way. Then then that's probably not a good idea. So what Mark was trying to show, and there's a concept called Parcel, which is a group, I think, in his lab that's working on this, is can we sort of conceptualize the problem, put a meta problem on top of it first, and then solve the problem sort of piecemeal, and then all put it together. So to me, that's another very interesting fundamental question that humans have. Should I live my life on a day-by-day basis? Should I have a plan? Where do I want to be in 2 years, in 5 years? Those sort of things, I think, because just planning my next move might not be so interesting. This goes back to even economics. The time preference. If it's very short, then or small. If I have a very small time preference, then I do things sort of in knee-jerk reaction type ways, which would be the equivalent of just writing programs line by line. Versus what if I actually take my time, think about it a little bit deeper? I can come up with much better programs. So this would be, I think, this would be the idea of large language models and code assistants. So I think these are very interesting questions, right? If you want to program, how do you program an agent that has the motivation to be efficient, for example, right? That could be an intrinsic motivation, efficiency. Another intrinsic motivation could be save compute costs. So it goes back to my first point, which is every intrinsic motivation in the end is just minimizing the cost function that you're given. And it comes back to cost function design, which is really a very interesting subject, I think, which is immensely interesting because it's a philosophical problem. It's of course a mathematical and it's a computer science problem. But how, what is my cost function, and then how do I program it? To summarize, talk at the human-centered AI Institute at Stanford by Mark Haber. He is a researcher there, and he spoke about three things that stuck in my mind. One is intrinsic motivation of agents, curiosity of agents, and then how can we use curiosity, which is another word for exploration versus exploitation. How can we implement that in code assisting large language models?